20 after you're absent, so pass that around. Okay, so just to reiterate, if you're going to the extra credit deal tomorrow, the best thing to do probably is to message me from each class that you're in of mine and say, I want this, I want my absences removed, or I want the extra credit. And then hopefully I'll do it right. Okay, so today we're going to go over roofs, and then we have a test on Monday, right? Yeah. Woohoo! Okay. We love test. Okay. So I'll go over the slideshow, and then we have a worksheet, and then I'll answer any other questions if we have time. Did I record this? Yes. Okay. All right. So low slope roofs, as the name implies, is any roof with a slope of less than 2 and 12. Do you understand what 2 and 12 means? Anybody not know what 2 and 12 means? Tell me now. Forever hold your peace. No, not 2 by 12. 2 and 12.
Right. It's 2 this way, and the right is 40.
Right, just like this little picture shows you. Okay. So there is no such thing as a flat roof, because what would happen if you had a flat roof?
The water would get in there and build up or whatever.
Right. It'd be leak city.
Yeah.
So because eventually the water would just deteriorate the roof, and there's a sign-in sheet, and you would have big problems. So the minimum slope on a so-called flat roof is 1/4 inch per foot, so that the water will drain towards the roof drain. The roof membrane require a minimum slope in order to honor their product warranties. So if you don't follow their minimum slope rules and your roof develops a problem, then they will not fix it for free, which is bad. Okay, roof deck is a structural surface that supports the roofing system. It can be wood panels, it can be steel, it can be concrete, a variety of different materials. Of course, this picture is showing wood panels. In this picture, you can see there's sheets of corrugated steel on top that are going to form the roof decking, and then they'll probably pour some lightweight concrete on top of that. So that's a steel structure, roof decking. And then, of course, there's roof joist, steel bar joist underneath that. So the deck must be strong and stiff enough to resist loads from the weight of the roofing materials themselves, any standing water that may occur in a torrential 100-year rain, snow. That's, we've heard of the stories up north when the Walmarts collapsed because the roofs weren't strong enough. For wind uplift, that's a problem down here with hurricanes. And then any kind of equipment that you anticipate being up there and people walking on it to repair the equipment. So the engineers will figure out the structure of the roof, but all of those loads come into consideration. There's 3 ways to create the slope of the roof. There's the slope structure, which is obviously on the left. The whole structure is sloped. A tapered structure where the roof framing is flat, but then the ceiling below is flat, but then the roof framing will be sloped. And then there's tapered insulation where the roof framing is flat, and then you have a material on top of that that is tapered toward the drain or wherever you want it to slope to. So the roof deck, it must be smooth so as not to cause distress or tears in the overlapping roofing materials. So you need to take care in how you place your deck so there's no sharp things sticking up that will cut through the membrane or whatever topping you're going to put on there. Here they're using a substrate board that is fastened over a wood panel roof deck and provides a suitable surface for application for hot asphalt. The substrate board is fastened with screws or oversized washers, and that is to, because if you just have a skinny little screw going down through there, you're more likely to have leaks. If you have the oversized washer, it protects not only against leaks, but it also puts that pressure where the screw is, it spreads it out over the board. Here's one way to detail a roof. You have the insulation below the roof decking. This is kind of normally how houses are done. You would blow that in, either put bad insulation or blow that insulation up between the roof joists. Then you have your, you have a little bit of an air space right there, and then you have a the roof deck, and then you have a membrane, like your tar paper or whatever system, and then in this case it looks like this is a flat roof, or so-called flat roof, and they're using, gravel, but you could also have there your shingles if it was a slope roof. So there's a sign-in sheet up here. Thermal insulation and the vapor retarder. The insulation below the deck, foil, right there. Oh, sorry. Foil-faced rigid foam insulation boards is what they're using here. Has a large R value. Bad insulation is placed on top of the rigid boards with a 1-inch airspace. That airspace is important to allow for ventilation. If you don't allow for ventilation and the water or moisture gets in there, you'll have mold and mildew and eventually disgusting rot and decay. So, sign-in sheets up here. And then both ends of the rafter bays are vented to the exterior. Here's another detail with the spray foam insulation. We saw that on the field trip, right? They were going to do spray. They hadn't done it yet, but that's the spray-in. That's the goopy stuff that expands and fills in all the voids. So it's air impermeable, which means you don't have to have the air gap because it supposedly is sealed. Of course, my fear with that is that there's always a little hole somewhere. But if they do it right, as with everything, if you do it right, it should cause you no problems. Here, the insulation is above the roof deck. And you have, because you can see the roof deck here, and then you have the rigid foam insulation, and that could be tapered or flat, depending on if the structure is sloped or not. Then you have the roof membrane, and then you have the topping on top of that. This is the way it's most commonly done because it's easy to slope that. If you have a flat structure, it's easy to taper that insulation to your drains. It's much easier to do that than to slope your structure, or even, if you had a lightweight concrete, to slope that. Here's some roof problems, obviously. They had some issues in causing bubbles. It wasn't sealed right, or moisture damage, and if they didn't do the proper sloping, like I said earlier, or they didn't follow the manufacturer's recommendations, the manufacturer will not guarantee that, and so they will just have to fix it on their own dime. But that moisture can come from below with humidity. There can be a pinhole in that roof surface, and it can seep in there and cause problems. Just a bunch of different ways it could happen. Here's a sign-in sheet. You're the last one. Everyone else is absent. It's 20 after. So, you also need to, when you have penetrations in your roof, you have to take care to detail that correctly. And this is a detail for that. Again, these are things you could copy for extra credit if you need it. And this is showing the metal roof decking, like we saw in that picture earlier, with a lightweight concrete. Then you got some some like tar layers, and then you got your thing, and there's flashing going over that. Then there's another layer of roofing, so it'll be very hard for water to get all the way down into there. Here's a picture of some insulation between the roof membrane. Insulation boards are often installed in several layers with joints staggered to reduce the air passageways or leaks. And you can see, if you overlap your stuff and you cover up that joint with a solid piece, it's less likely to have leaks. So this is, again, the insulation above the roof membrane. And that can help protect. The membrane is something that can be damaged if it's exposed to the UV rays. So when you put your insulation above that, that also helps protect that. So it acts as a moisture barrier, and then you got your insulation, and then you cover that with the gravel or some sort of coating to protect the insulation.
So what were the three ways? It could be below the deck, it could be above the roof deck, between the roof deck, and then this is above
Above the vapor or the
the roof membrane.
membrane, yeah.
So there's 4 ways?
I'm not sure I have to. Did I say there was 3 earlier?
No, but it said at the beginning of this like section, it said there's 3 ways.
Yeah, I see what you're saying. Okay, so there's one, insulation below the deck, yes, like you said, and it has to have the air gap.
And then above the roof deck.
And then insulation between the roof deck and the membrane.
Okay.
So that's just like right on top of the wood.
Not those 2.
And then the third one is above the roof membrane,
Okay.
and that helps to protect the roof membrane.
Okay.
Okay, so here's insulation boards may be made from different materials, various foam plastics, perlite, mineral fibers, cellulose, and cellular glass beads. And here it's basically some square foam things above this roof deck. In this case, they don't have the concrete because probably there's not, as you can see, there's not a lot of, people won't be walking a lot on this roof, and they don't, it's not a, doesn't need to be as structurally solid. Here, rigid insulation materials for low slope roofs, lightweight insulating concrete is what they've used here. 7 times lighter than conventional concrete, easily sloped, and can accept nails and other mechanical fasteners. So they put that, if you're going to have concrete on your roof, it's usually lightweight, of course. And they use the different, the perlite or volcanic stuff that makes it lighter aggregate than the concrete you put in a sidewalk. Here's a cover board, maybe applied over the insulation under the roof membrane. That would help to improve the fire resistance, provide a suitable surface for adhering hot mopping roof membranes, separate the roof membrane from the incompatible insulation, or separate the roof membrane from new roof membrane from old roof membrane. Vapor retarders restrict the passage of water in a gaseous state through the membrane. It doesn't really restrict solid water. It's just, you know, the humidity and the moisture and stuff like that when it gets into a gaseous state. They are always placed on the warm side of exterior walls and roofs to prevent the rise in humidity and the formation of condensation. In the south, where we are, we put them on the outside of the wall. In the north, they put them on the inside because that's 90% of the year it's warmer inside than outside. So you have to understand the climate you're building in to make sure you build it properly. And that's an important thing to remember, especially if you move away from here. These are the different types of membranes for low slope roofs, which is anything under 2 and 12, remember. You've got the bituminous, which is built up or modified bitumen. You've got the single ply, which is elastomeric or thermoplastic, and then you got fluid applied, which is the neoprene, silicone, and all those. And it goes into detail. I'm not going to read them all to you because that's something you can study in your reading, or you can go back through these slides and read it. But it describes each one of these, and they all have specific purposes or why you would use them or not. Built-up roofs, obviously, as it implies, they're built up. There are several layers, and they're overlapping, as this picture shows, so that no matter where you are, you're going to have at least 2 layers of this membrane because it's all overlapping. And then they put the hot mop over that. Here you can see another diagram of that. In this case, there's 1, 2, 3, 4 layers. So that's a 4-ply built-up roof. And depending, again, what the manufacturers call for or what your specific needs are, it'll be 2-ply, 3-ply, 4-ply. A lot of times crushed rock or gravel is embedded in the asphalt. That adds another UV protection because, again, you don't want the sun just beating down on that roof membrane. It'll deteriorate it quickly. Modified bitumen roofs is what it's talking about here. Here they're using the torching method in this picture. It's obviously a hot application. Here it's kind of a welding. They're putting the down and they're pressing the seams kind of like an iron or weld. Like I said, y'all can read through these. I don't want to read through all of it because I want to do the exercise. Single ply obviously is unlike built-up roof. It's one layer of a certain, and that's obviously probably the easiest thing to put down, but it probably also requires a more skilled worker because one mistake and you're toast. You got a leak. The other way is more forgiving because you have several layers to take up the slack if you make a mistake. One good thing, I mean, they come in all types of colors now. I don't know if you're in a plane and you ever see the roofs that have big designs on them. It's probably this type of either painted or has this type of membrane on it. And one thing to keep in mind is the reflectivity of your roof. The lighter the color, generally, the more reflectivity, and then you'll have a cooler indoor temperature. An example of that is we used to live in a house, that just had a regular asphalt shingle roof. It wasn't a black roof, but it was a dark gray. And now we live in a house that has a white aluminum roof. And that's just like a mirror, And so even though our house is twice as big, our electric bills are half as much as they were in the smaller house with the dark roof. So keep in mind that when you design your house. Here's they're applying the single ply roof membrane, and they have mechanical fasteners with the oversized washers again to protect it, and then they overlap that, and then there'll be some sort of I think there'll be some sort of seam that presses it down like an iron. And this just describes the science behind it that you could read to understand more clearly. PVC is one type of the single ply. There's the ironing machine I was talking about. That sort of like presses the two edges together to keep them sealed. EPDM is a very popular, I've specified that before on jobs. And you can, I think that's the one you can walk on. Like if you want to have a roof deck, if you have a flat garage or something, you want to have a deck on it, you could put an EPDM surface on there and walk on it. Here they're going to seal it with some double-sided tape. So the good thing about single-ply roofs is that their construction is done in a factory, so it's just like precast concrete. You can control all the circumstances. There's not going to be, as many mistakes. But then in the field, you have to apply them with care so that you don't accidentally have a leak area. Fluid applied membrane. Which obviously is good because it's like the insulation that you spray on. This will creep into all the nooks and crannies. Have some leaks. Here's a structural panel, just a basic metal roof. Now, what do you think you have to do when you're sloping this? It says right there, but obviously the water can't jump across these little ribs. So when you're applying this, when you have this kind of roof, you have to make sure you're sloping it with the line of the panels. And that's just a detail of the clips that you would use to connect the different pieces together. And it kind of overlaps so that, again, water won't crawl up through there. And that's just a diagram showing who uses what. We're going to do an exercise, I think it's similar to this, talking about drainage for low slope roofs. The difference, when you have a pitched roof, let me do it on here because I'm recording this. Hold on. When you have a pitched roof, your slope goes up. and all the water will go downhill each way. When you have a flat roof, or a relatively flat roof, usually there's a parapet wall on the end. I'm drawing a little section here. So you can, have a single slope all the way down to here and then have some sort of scupper through the wall that lets the water flow out. Or, more commonly, depending on the size of the building, you will have sloping on your roof that goes down, in different spots. I can't draw it very well on here, but then there'll be a roof drain right here and right here, and that will go out and out somewhere. Does everyone understand that little sketch? Okay. Crude little sketch. Okay, slideshow, current slide. Oh, no, I got to do this again. Hold on. Okay. Oops. So you can see this is a flat roof, and this is your edge of your roof that they've drawn here, and then it could be a parapet. These are the drains in each section. So you want to figure out how you're going to slope this. So if your slopes are the same, like this is, what does it say here? 1/4 inch per foot. Your lines are always going to be at 45s, just like on a roof that's pitched. If your slopes are the same, your lines are always going to be at 45 because that's just the way the geometry works. So you can draw a 45-degree line there, a 45-degree line there, and where they meet is going to be the low point. Same with over here. But then you've got this odd spot here, so you need to make a cricket. A cricket is where you build up just to make, some slope there, and I'll just draw this here. So that roof has, it's going down to that drain there, and then there's another drain right here if we're looking at a section. So this is flat if you didn't put that cricket in there. So if you put that cricket in there, you're making a little hill there that's going to allow the water to go like that.
Why don't they just make it like that in the first place?
Hmm?
Why don't they just make it like that in the first place? With slope.
Well, they are. I'm just saying what the cricket is.
Okay.
So, yeah, they wouldn't leave the cricket out. But that's a cricket. And then obviously this one is a little bit easier because the 45s actually all kind of meet in the middle. So you can have your roof drain there. Now this, you also use crickets at chimneys. This is something that's sticking up out of the roof. I don't know what it is. Does it say? Some sort of equipment. So the water's going to come sloping down to that, and then it's going to hit whatever's sticking up there. And if it's big enough, it's going to pond behind that and cause a big leak. So they made a little cricket. They built it up, and then they're sloping it off to the side each way, so it'll go around and down to the drain. Does that make sense? Okay. So I think in a little while we're going to do, yeah. So you may want to come back to this slide to look at it. Here's a roof. When I said, you could slope all the water down to one side, this is what that scupper or that drain would look like. So you have a roof edge, then you have your, well, here's your roof deck. We'll start at the bottom. Then you got your insulation. Then you got several layers of membrane. Then you got stripping, it's called, or flashing, I think is what I would call it. But and then there's flashing here, and then that overlays that. All these different overlaying areas, and you just got to think about where the water's going to run so it never goes underneath those. And then this water will run over here and down the drain. Here's a roof parapet wall that's on your flat roof, and you can see that the roofing membrane goes up the wall and then under all of this splashing. And then you got your roof gravel over here, and this roof probably has a drain out here in the middle somewhere that it's going to slope towards. And that's called counter flashing when the metal counter flashing covers the roof membrane. So this flashing comes up, loops into there, goes under there, and that flashing overlaps that, goes up there. You also have to have flashing around your roof drains. And you can see the slope of this right here. They've sloped their insulation to the roof drain. Then there's flashing, a large area of flashing. And then there's two more pieces of, well, they call it stripping, but it's more like roof membrane. So also one thing you have to do a lot of times is have the regular drain, and then you have to have an overflow drain, which if something leaves or crap gets clogged up in here, then you got your overflow drain so the roof doesn't just fill up with water. Here's a side view, which might be easier for you to understand. And again, you could draw this for extra credit. So here you got your metal deck, you've got your insulation, then you have your roof membrane. This is a single ply roof membrane, how they would do it. And then you have flashing that goes over. Here, this is your concrete wall, and you got a 2x there. So you got flashing that goes over that. You got some counter flashing or under there. Then you got this flashing that goes over on top of that. So it would be very hard for water to crawl all the way into there. And there's a side detail of a wall with a single ply membrane. Same principles. There's your membrane. Here's your probably a membrane flashing. Then you got counter flashing and all that. So again, water would have a hard time getting up and down into that wall. So next is the steep roofs or the sloped roofs. We're all familiar with shingles, which are basically small overlapping roofing units with staggered joints. And you can see that here. A joint there, and then you got a whole one on top of that, a joint there. So it makes it very hard for water to get through the layers. Wood shingles and shakes. I don't think they're used quite as much. Well, they're not used at all around here because we don't have forest. They're mostly used in forested areas, but they're also, they probably have treatments now they can put on them, but it used to be a bad fire hazard because sparks would come out of your chimney, hit your cedar roof, and poof, your house is up in smoke. So I wouldn't use one on my house, but it is an option. They are pretty, and they have a nice look to them if you want that kind of look. And this is just talking about wood shakes, difference between wood shakes and wood shingles. Y'all studied that in your book. This has to have a lot of airflow, so you don't have a solid roof decking when you do this. It's called skip sheathing. So you have a nailing space, and then you put your wood shakes and shingles on top of that. But this allows a lot of air to keep that all very dry, and so the moisture doesn't get trapped in there, and you get a bad situation of mold and mildew. And here you can see well, they're saying here it depends on where you are. If you have a wind-prone area like we do, you have to have the solid sheathing because that's required by code, but then you have to do other things. So, but the other way, the previous way is the more traditional way, is how it was done in the beginning before we had all these scientific materials. There's a breathing mat, which again, it's kind of like, looks like that stuff we used in the brick walls to keep the mortar from dripping down to the bottom. That allows the air to flow freely through there so that they stay dry. Just some properties. Like I said, they're vulnerable to fire. But they do have a unique natural appearance. So when you use these kind of shingles or shakes, is a minimum slope of 4 and 12, because if it's too flatter than that, you'll have a water problem. Shingles, your minimum slope is 3 and 12. And you can expect those kind of roofs to last anywhere from 15 to 25 years before you have to redo it. Asphalt composition shingles is what we're used to seeing around here. And those are, in reality, those are big sheets that are like 3 feet wide with with these tabs in it. So when you put it on your roof, it appears it's little shingles, but it's really not. They're tricking you. So, but that's very, I mean, they've come a long way. You can get asphalt shingle roofs that are guaranteed up to 30 years now, I think. You can get different colors, and get, the lighter the roof, the more reflective. And these are all the, there's more colors than that. But these are many of the types. You can also get different shapes to give a different appearance. And shading, this is still an asphalt shingle roof, but it looks more 3D because it has that different coloring in there, which might make it look more like a slate or a tile roof. And that's a demonstration of how you would apply that kind of, again, you always start from the bottom and you go up so the water will go downhill. So you put your tar paper on from the bottom, and then you put your shingles on from the bottom. And over here, if you're hitting up against a wall, you'll have to have some flashing that goes underneath the shingles from the wall. We're just showing you the metal drip edge. It's still important to have that because if you don't have that drip edge, which makes the water fall away from the building, it will just run down the side of your wall and cause stains and corrosion. Here's how they would do the valley. A valley is where the two slopes come together. Oops, sorry. So there's several ways to do it. You can either have the open valley with this flashing, and then the shingles kind of go on top of that. You can have the woven valley where they overlap each other all the way up. Or you can have a closed cut valley where one is going up and then the other is just cut off at the seam. So here it says it lasts 15 to 25 years, but I know I've specified some. Of course, they're more expensive that last 30 years. The lowest slope you can do is a 2 and 12, but that's pretty flat. I tend to like to keep it at 4 and 12 or above that, just because it's safer. You want the water to drain. You can have mineral surfaced roll roofing, which can go down to 1 and 12. And this is probably good, in those situations where you want to create a porch roof or something and you want it to run into where you got the edge of your house like that, and then you want a little porch out here, so you want a low slope roof. So you would put that kind of, you're not going to really see it. You're not going to, because it's kind of ugly if you look at it. But it'll provide, enough waterproofing on that area. You got slate shingles, which are very expensive, heavy. They can last up to 60 to 80 years, but then you would have to also beef up your structure because of the heaviness of it. So if you're going to be in your house 80 years, I guess it's worth it. So, clay and concrete tile is another one. It's common, especially in, down toward Mexico and in Italy and all those areas, because they have an abundance of that material. But again, it's heavy, so you have to beef up your structure, and then they can last from 30 to 75 years. But you have to be very careful with these, because obviously you can't really walk on these roofs, or you'll bust the tiles. There's sheet metal, rubber, reinforcing. These are just different materials. Aluminum roof shingles, and then copper roofing shingles, which I think that would probably get stolen if you put it on your house. Architectural sheet metal roofing. This is, you see this on churches and monumental buildings. You want to have that look of the patina that happens when when it changes colors. It's also very expensive, but it's for monumental or important structures, it's a good choice. There's a sheet metal roofing, again, where I think there's a detail in a minute where they overlap the seams. And that's lightweight, and it's very cool because it's reflective. You can even get darker colors, and it still reflects better than shingles, which just absorb the heat. There's a zinc galvanized metallic coated steel and I've seen that when it comes out the truck, and it forms it right there on the site, and they cut it at the lengths they need, and then they take it up to the roof. I think they might have a picture of that. No. This is flat metal seam roofing, and this you can see how the metal interlocks in that detail so that, you know, water would have a hard time crawling on in there. This is soldering a copper roof, which again, I just think in the middle of the night someone would go up there and rip all that off. So, standing seam, here's what I was talking about earlier. You have your, this is how they fold it so that it interlocks, and then there's no moisture getting in there. Here's another copper roof, standing seam copper roof. Batten seam metal roofing is where they would put a little piece of wood in there and to give it a thicker appearance. I think that would be the only purpose. I'm not sure. I've never seen one done that way because I think it's probably tedious and more expensive. But there's one on top of a, I mean, maybe it's good with the copper because copper's kind of a very soft material. So it probably adds some stiffness to that if you're going to do that kind of roof. Here's an architectural sheet metal roof again. They're expensive, but then they last longer than asphalt shingles. So, you know, it's the time cost analysis that you got to think of when you're going to replace that roof. Here's the machine I was talking about. It spits it out, and then you cut it at the length you need. There's different thicknesses, and of course, probably the thicker the better, but the more expensive. So you would specify, I mean, if you're doing a barn roof, that's probably pretty thin, but if you're doing a home roof or some sort of monumental structure, you'd want it to last a lot longer. So that's all in the specifications as to how the gauge you want and how thick the roof needs to be. Just more information on that. One thing you got to be careful of is corrosion. You can't put different metals with each other or they'll corrode. They'll cause some chemical reaction and they'll just deteriorate. And this is a chart showing you the difference. So this is the most cathodic and this is the most anodic. And so you could probably put zinc and aluminum pretty close together and be okay in these two. But as you get further apart on this chart, you want to not let those metals touch. So like if you have a stainless steel thing and you put galvanized screws in it or something, you're going to have a corrosion problem eventually. So that's just something you got to be aware of. And if you're an architect and you're going out into the field and looking at how they're attaching things, you want to make sure they're using the same type of nails or screws or close enough to it, to the metal they're attaching it to. Sustainable roofing is green roofs or grass roofs, like we talked about, or cool roofs. With the green code coming out, you know, everybody wants to have a cool roof, and that's one that will reflect the heat and keep it out of the building. Or, you know, and green roofs or garden roofs do that as well. They absorb it and they use it. This is talking about reflecting in this particular slide. And the solar reflectance index that they'll talk about. Reducing solar heating on roofs reduces the cooling loads on the buildings and increases the life of the roofing materials. So, white or light colored roofs, like I said earlier, are very cool roofs because they keep the structure cool. They reflect it. Composition shingles with a cool color or metal roof with a cool color. And also even some of these can be termed or claimed to be cool because they'll have little reflections or sparkly things in them that will reflect. So the color may look dark, you know, how can that be cool? But actually it is still reflecting because it has those little sparkles. They're bedazzled, I guess. Here's a garden roof. Of course, with this, it's very important that you detail it correctly. because there's massive potential for leaks in this system. But you know, again, if it's done right, it can be a very good environmentally, you know, improving the environment and replacing the, you know, basically this replaces the vegetation you removed below when you built your structure. So you're not taking away from the environmental air quality. This is just the terminology. An extensive green roof has 2 to 4 inches of soil. An intensive has up to 36. This is an intensive green roof. These are the different, you know, layers. You'll have to have, obviously you'll have to have a beefed up structure because you're going to have dirt and stuff on top of it. So most likely you'll have concrete, and then you'll have a barrier, a waterproofing membrane, and then you'll have a protective root barrier, this thing that keeps the roots from poking through and penetrating that. You'll have some rigid insulation, I think, or maybe that's the dirt. You have a drain. I went backwards. Well, you can, I guess we'll go from the top. You got plants, then you got dirt, then you got the filter fabric that keeps the dirt from going down there. Then you have the drainage aeration barrier that allows the drainage. Then you would have, see, they don't have, unless that's the rigid insulation, but that looks like the membrane there. See, I don't think they're showing everything. But that's, I mean, it's an intensive buildup of stuff. And I think this is a movie on, so on this exercise sheet, let me go back to that picture. Where is it? There it is. Okay. On the roof plan, well, this is a slightly different roof plan, but the one on the bottom is kind of similar. But for number 1, it says, on the roof plan to the right, add arrows indicating a slope. Assume a slope of 1/4 inch per foot and label the roof high points. So that kind of looks like this one, right? This section. So you got your roof drain in the middle, and you're going to add your arrows showing which way the water's going to flow.
Towards the drain, right?
Should be, yeah. Okay. And then you're going to calculate the high points. Obviously, the drain is the low point, and no, because this is all one level right here. It's like it's sloping in one direction, and this, like, just this isn't the right answer, but like that's a foot high, and say it's all sloping down to 0, and that's causing a valley in this corner. Do you understand what a valley is? Yeah. Okay, so the edge of the roof is going to be the same usually all the way around, and then these are where the different slopes meet. So this is one flat plane in this area, and this is one flat plane sloping down, and this is one, I shouldn't say flat, one plane sloping down, like an upside down roof. Okay, okay. So if this is the low point in your picture, it shows that you have 35 feet from middle to the edge. So you got to figure out, if you're sloping at 1/4 inch per foot, how much higher is this going to be if that's 35 feet? So you got to do that calculation. And it says on C, if the roof edge can rise as much as 16 inches above the drain level, what is the maximum possible slope? So first you figure out what it is at 1/4 inch per foot. Then you go back and say, okay, this is going to be 16 inches above, and you kind of go backwards and see what's the biggest slope you can get. So try to do that first. And then, do you want me to go over number 2, or wait till you finish number 1? I'll give you, we have like 15 minutes left, so I'll give you 5 minutes to do number 1. Okay, has anyone figured out, I mean, obviously you probably all got your arrows, right? You got that on there. So does anybody figure out the high point?
The edges of the roof.
Yeah, but how high is it? If you're assuming a slope of 1/4 inch per foot, you're going to label the high points. So this is the low point. You got 35 feet. So it says the horizontal, this is the low point. You got 35 feet to there. The horizontal run is 35 feet. So 35 times 1/4 inch per foot, or 0.25, is going to be 8.75. So the high point of your roof is going to be 8.75. Yeah, you're smarter than you thought. Okay. And then C says if the roof edge can rise as much as 16 inches above the drain level, what is the maximum possible slope specified to the nearest 1/8 inch? So for that one, you would just say, okay, now my roof edge can be 16 inches above the drain. And you know that from here to the drain is 35 feet. So you go backwards. You say 16 inches divided by 35 feet is going to give you 0.46 inches per foot. But it's asking you to say the nearest 1/8 inch. So 0.46 is a 1/2 inch per foot, or would round up to a 1/2 inch per foot, but that would exceed 16 inches, so you got to go down one, so the next 1/8 inch would be 3/8 inch per foot. Does that make sense? So the maximum slope would be 3/8 inch per foot, not to exceed 16 inches on the edges. And just so I'm going to explain real quickly the number 2 one, and then if you finish it, you can give it to me today, or else you can turn it in next time. So number 2, it says add arrows indicating the slope, which you can pretty much copy from here. And then it says assuming the high point on the central cricket, which would be right here. This is the high point of the cricket, this middle line on your drawing. It's a little different. I'm just using this as an example. So assuming the high point on the cricket is 6.25 inches above the drain, which is, the drain's right there, what is the slope of the cricket? So you kind of got to go backwards the 1/4 inch per foot and figure that, the slope of the cricket. Then, let's see, assuming the remaining roof surfaces slope, this is C, slope at 3/8 inch per foot, label the roof high points. So over here you labeled them at 1/4 inch per foot. Now you're going to do it at, for this roof, you're going to do it at 3/8 inch per foot, and you're going to do the same thing we did on number 1, except with 3/8 inch per foot, and figure out the high points. And then finally it says modify the roof plan so that the slope of the cricket matches the typical slope. Either way would be fine in the end, but you would redraw these lines to match the slope of the rest of the roof. And I'm just going to see if you can figure that out. So I doubt you'll finish in 5 minutes, but you can turn it in next time. And then next time I put on the discussions, I think I put a list of terms to review for the test that was going to be on Monday. So be sure and come. I'd like you to take the test here. If you're not here, you're absent, even if you take it away from here. So that absences count. So I would prefer you be here, and that way if you have questions before we begin, I can answer them if you're here on time. If you're late, you'll miss the question answering session. So.
Did you say you're going to put
I think I put it.
or you haven't done it?
Oh, I haven't done it yet? I will if I haven't. I know I made it.
Because the most recent discussion is...
Okay. I'll do that right after class because I've made it. I just have to post it then. So it's just going to be in the discussion area, and it'll be terms, basically from the chapters. So look for that shortly. So if you finish this today, again, you can bring it to me or bring it next time.